Hello and welcome to another edition of AC with Wacy. This video is going to be in response to some posts that we've seen coming up on social media about people's electric bills doubling or more through cold spells and kind of people upset at electric companies that shouldn't be upset at electric companies. And we're going to try to help explain why that happens with heat pump systems specifically. I happen to have a heat pump and electric furnace low voltage system set up in my shop for training, so I'm going to kind of use that to try to explain why your power usage comes up. So we have here just your standard single speed compressor heat pump. There's a valve on the inside that the way the heat pump works is your Freon runs one direction during the cooling and pulls heat from your indoor air and takes it outside. Basically your Freon absorbs it, it goes outside, and then it's released throughout your outdoor unit. That's why you have hot air coming out of your fan motor during the summer. And then in the winter, it will actually reverse the flow of that Freon the other direction. So instead of your outdoor coil getting hot and your indoor coil getting cold, your indoor coil will now get hot and your outdoor unit will now get cold. That's why you'll see frost on these, and you'll see them defrost once in a while. That's where your fan motor shuts off and steam comes off your unit and all of that. So this works really good for heating, but it is a limited heating selection. So on a standard unit like this, it's drawing heat out of that outdoor air, but this unit is a 4-ton. I don't know the specs specifically on it. 4 tons refers to 48,000 BTU capacity. However, every 4-ton is not the same. Some of them are 44.5, some of them are 46, some of them are 45. Let's say that this unit has a max capacity of 46,000 BTUs. If your house takes 46,000 BTUs on a normal day to heat, what happens when it gets cold is your house now needs more heat. It's needing, let's say that it needs 48,000 because it's 34 degrees outside, and your house on that day needs 48,000 BTUs to heat. This is going to need its full capacity to do that. The problem is with a heat pump, the colder it gets, the less capacity it has. So somewhere around freezing, and every heat pump is slightly different, but most single stage heat pumps are going to be somewhere around the freezing point, it will begin to lose capacity. So instead of the 46,000 that it normally puts out, maybe it's putting out 45 at 34 degrees. And then at 30 degrees it's putting out 40. And then at 25 it's only putting out 25. You know, keeps dropping as it gets colder, and it's not a linear line. It drops pretty quickly past, once it starts losing capacity, that capacity drops pretty quickly. So knowing this, heat pump, the way heat pump systems are set up, you have an auxiliary heat to help boost that capacity. Most systems are set up with electric. So an electric furnace uses resistance heating coils to heat. So in this particular one, this 4-ton setup, you can see there are 4 of these strips in here. That means that you have 20 kW of auxiliary emergency heat. So if wired up properly, when your auxiliary heat comes on, you should only bring on 2 of these heat strips, and it'll add this heat to the heat being produced by your outdoor unit, and it'll be able to hold your house there. So at a certain point, your outdoor unit isn't producing enough heat to really be worth running it. Not only is it using power, but that compressor starts to have a whole lot of pressure on it. Because it's in a low pressure stage, it can damage that compressor and fan motor. So what we typically tell people is when you get down to 20 degrees, you should be shutting off your regular heat and you should switch to emergency heat. Emergency heat will now use all 4 of these heat strips in here to heat your home. And it'll save wear and tear on your outdoor unit, as well as quit running that outdoor unit while it has no capacity. Alright, so the spike in electrical usage. Your heat pump, your outdoor unit, when it's running, will typically pull 15-16 amps. Vary by unit. Some of them will get up to 20. Some will be slightly below that, but 15-16 is fairly average. Your indoor fan motor, which isn't hooked up in this unit, but this is where it would be, will pull about 1.5. So your entire heat pump system without the auxiliary heat pulls about 17 amps, 18 amps, something like that. As soon as that auxiliary heat has to kick on to help it keep up, each one of these heat strips will pull about 20 amps. So if you kick 2 of them on in auxiliary heat to help your heat pump, you now have the 18 amps of your heat pump system, and then you have roughly 40 amps of auxiliary heat. So you just tripled your power usage with that auxiliary heat coming on. And then when it gets down below 20 and you have to switch to emergency heat, you're now kicking all 4 of these on, and they'll run just over 80 amps plus your fan motor, so you're up to 82 amps. So you are at 5 times the power usage of what your normal is. So if we are in a cold snap of 5 or 6 days to where your electric heat is on for 3, 4, 5 days, you are going to use 4 or 5 times as much power through those days as you normally would heating your house. A lot of you are going to question why there's not a better way to do this. And the answer is there is. One way that is a little more efficient is to use a gas furnace to back up your system rather than an electric furnace. Obviously your power bill goes down, but you have a gas bill. So the way that we prefer is to get a more high efficiency heat pump. I'm going to walk out to my scrap pile here where I happen to have a 2-stage. So with a 2-stage unit, you have a low and a high speed. The majority of the time, the low speed is enough to take care of your home. Under high load conditions, when it's extremely cold, extremely hot, you'll use your high stage and it'll produce more BTUs and you can heat your home better. Because it's a 2-stage, typically the compressor will be able to generate heat to a lower temperature outside. I still tell people with 2-stage systems that at 25 you're losing capacity. Typically around 15 you're needing to switch to emergency heat. So this unit is a Samsung unit. It is a variable speed compressor. You see variable speeds on very high efficiency. Trane, Carrier, all of these brands have a variable speed unit as well, but I just happen to have the Samsung sitting here. I love the Samsung Hilux system. It's a variable speed system that will hook to almost any indoor unit. You can just change your outdoor unit. And in these variable speed systems, the compressor can amp itself up while speeding this fan motor down. And what that does is it manages to keep that heat being produced to lower temperatures. So on the Samsung Hilux, the variable speed system that I like to use, I have one on my house. I didn't even hook up a heat kit. I installed it, but I didn't wire it in to be used because I wanted to know, because specs on it said that it would heat down to -15. So I wanted to know if I actually needed it before then. I believe the night that we had snow here around Stephenville, they said the wind chill was somewhere around -13. My Hilux unit, my thermostat was set at 70 and it was 68 in the house or 67, something like that when I got up in the morning. As the sun came up, my house caught back up within an hour or two. But it did just fine in the negative temperatures, and I never had a heat strip kick on. So my electric bill will likely be the same as it normally is every other month, because it did not have to add 20, 40, 60, 80 amps into my system when it was cold outside. Provides significant savings over the winter. So my normal heat bills last year, when it got cold, would be $400. I have a video set up to show the exact comparisons on my YouTube page if you're interested. But I'm saving several $100s a month compared to last year when it gets cold. The main reason is when you have to kick this auxiliary and emergency heat on, you're not just doubling your power, you're tripling, quadrupling. You might get as high as 5 or 6 times as much power. So just keep that in mind. Electric companies and the receptionists there have a hard enough job. Try to keep from overloading them. It's not their fault. Your electric usage does go up, and it goes up significantly because you have to use that auxiliary and emergency heat. If you're looking for a way to get around that, give us a call. Or if you would like a better breakdown or you didn't understand something, give us a call and we'll explain it as well as we can. And then if you're interested in doing something like the Hylix system to get a better system, not only more efficient in the heating, but more efficient in the cooling, give us a call. We'll walk you through that. We'll get you some pricing and see if it'll work out for you. In the meantime, thanks for stopping by, and we'll catch you next time.